Hello everyone, this is Unofficial Sando. Today, let's take a look for the problem Leetcode 684 redundant collection. You like me videos? Please subscribe me my channel, and you can find a complete problem list in video description below. Let's look at the problem first. We are given a graph. The input is all the undirected edges for the graph. Then we ask to return an edge that can be removed. So the resulting graph is a tree. Basically, what this means is basically it's kind of indicative we use a unified algorithm to solve these problems. Within using a unified, you can end up with a single parent, which is a tree. And also, if there are multiple answers, we need to return the answer that occur last. Let's look at the first example first. We have 1, 2, 1, 3, and 2, 3. So the final output is 2, 3. So actually, there is three options we can remove, right? We can remove 1, 2. It ends up 3 as a root of 3. We can remove 1, 3. Then 2 is the root of 3. The answer is return the last one if we have multiple one. If we remove 2 and 3, 1 will be the root of the tree, and 2 or 3 will be the 2 leaves. Then let's look at how we use the unified to solve these problems. I'm using the second examples to explain the algorithm. Here we have 5 edge and 5 nodes. Given by the order. First is 1, 2, second is 2, 3, third is 3, 4, fourth is 1, 4, fifth is 1, 5. In the end, if we remove 1, 4, we end up the graph like this. There's several tree we can explain by this. Either 3 can be root, 2 can be root, and 1 also can be root. To implement the unified, we'll come up a parents table. So the row means the index of the node. We have 1, 2, 3, 4, 5 index, and the columns colored by yellow means the corresponding nodes parents. And we also going to, when we iterate all the edges, and we see how the change of the parent table will be. To initialize all the nodes, its parent will be itself. Then first we check the edge of 1 and 2. So we union 1 and 2 together. So it doesn't matter 1 be parents or 2 be parents. If you are not using the union by rank method. But if you're using union by rankers, there will be a preference which node should be a parents of the unions. So here, if it doesn't matter, we choose 2 as the new parents of 1. Right, 3, 4, 5 we keep it unchanged because 3, 4, 5 is still not unioned. Then we come to edge 2 and 3. We union 2 and 3. Right, we union 2 and 3. Here we choose U3 as the common parents. One thing we need to keep in mind that we also want to change node 1's parents, because node 1's previous parents 2. Now we set parent 2's a new parent 3, so 1 has to be changed to 3 as well. So next, we come to the edge 3 and 4. To determine which edge we need to return last, we will check whether 3 and 4's parents are same. If the same, we will return the edge. So right now, not 3 parents 3, not 4 parents 4. It's still not the same. So we continue to do the union. Here we choose to make common parents still as 3. So not 4 need to be changed to 3. So in the end, we come to the edge of 1 and 4. So we check each parents. So node 1's parents 3 and node 4 parents 3. So right now we got the same parents, which means this edge is not necessary to generate the tree structure. So we directly return the edge here. Then let's look at how what's a template to implement the union find. Here we input the edges, then we create a array of the parents table. So it's an array. So here we take the big of n of the space complexity. Here is a lambda functions to implement the find parents and the path compressions operations. Let's talk about this later. Let's look at the main function first. In the main function, we iterate all the edges. Then if those corresponding node parents has not been updated, we put it itself. Then we find the corresponding parents for each node. Then we go into these lambda functions. Here we do the path compressions and also find the parents of the node together. So basically it's kind of bottom up operations to update all the parents and also find the root of the whole unions. I don't find a pretty good intuition for this. So for me, especially, I just memorize this small piece of code when every time I do the this operation. So maybe like if you have better ideas, please comment. Or yeah, I think memorization may be the only case to remember this template. So after we find all the parents for each node, we will compile them. So if that's same, we return the edge directly. So since these problems ask to provide the last one edge, yeah, I think this maybe we need to reconsider whether we should record edge in a temporary variable and return eventually, or actually this way is past all the test case. I'm not sure whether its test case is complete enough. So maybe here we need to consider have a temporary variable to record this and keeping update that if we find the edge later and return it last. Yeah, maybe I think this some corner case will miss in the code. So but anyway, so if the parents are the same, we will return. If it's not, we will update the parents table. So the space complexity is big of n because we create a new array to store the parents. Then for the find parents operations, it's kind of function of n because using path comparison, we in worst case we won't have the to update all the whole tree if the whole tree is a list, right? Then here the worst case we need to iterate all the edges. So it's if the edge number is bigger for m, so it's m multiply fn. So here I didn't implement the union by rank method. So keep in mind that there's two tricks generally to implement union find. One is path compression, which is I described here. Another one is union by rank. To implement this, you need to create a new array for the order nodes rank, right? So once we update the common parents, we need to add in the rank for the corresponding the new parents, and here we will choose which parents has a larger rank. We make it as common parents. So if we implement both two tricks, in theory, the computation complexity become big of n multiply accurate functions of n, and the space complexity is still big of n. All right, so that's all the contents today. And if you want me to talking about some specific problems, or if you have any question for these videos, please comment.